is going on, Algebros? Wanted to make kind of a fun video here discussing whether or not 1 is a prime number. If you've ever wondered that and aren't sure, well, this video should get you started on the right track. So I'm pretty sure we're all familiar with what a prime number is, as well as the fact that any number that is not prime could be factored into a product of primes. But what about the number 1? Alright, so to jog your memory a little bit, if we had a number such as 24, you could write this in factored form. Maybe you start off with 2 times 12, or maybe you do 3 times 8. But in its complete factored form using only prime numbers, you could write this as 2 times 2 times 2 times 3, which using exponential format would be 2 cubed times 3. Now that's essentially 8 times 3. Okay? There wouldn't be any other way to write this though, other than 2 to the third times 3. Let's take a look at another number. One of my favorites, 313. Well, it turns out that 313 is prime. So I couldn't break it down as a product of prime numbers other than itself. Here's another one, 5109. If you want to take a moment to pause the video and see if you can factor that into a product of primes, go for it. And once you do so, you'll find out that you could write this as 3 times 13 times 131. All three of those of which are prime factors. As a last example, I have 7,872. And you might be wondering, why did I pick this number? Well, honestly, I've been listening to some music from when I was younger, and I came across a song by Limp Bizkit where Fred Durst sings 1, 2, 3 times 2 to the 6th, and then, LIMP and so on and so forth. Or anyhow, in this fully factored form, this would be 6 factors of 2 times 1 factor of 123. And of course, it's exponential format, which I already have here, is 2 to the 6 times 123. The whole point in doing all this is to illustrate something called the fundamental theorem of arithmetic. It says here that every integer greater than 1 is either a prime or a product of primes. So let's assume that we have a number n that's greater than 1 that's also an integer. It says that n is uniquely expressed as this. N equals p sub 1, which is a prime, to the power of k sub 1, which is a natural number. That would be a number like 1, 2, 3, 4, 5, 6, and so on, times p sub 2, which is a different prime than p1, to possibly a different natural number power k sub 2, and so on and so forth. We have examples of this already earlier in the video. Alright, we have 24, which is not prime, but it can be uniquely expressed as 2 cubed times 3. 313, that's prime itself, so that's the only way to factor that. We have 5109, that's 3 times 13 times 131. And of course, the Limp Bizkit number, 7,872, which factors as 2 to the 6th times 123. Every number can be expressed in this format. And again, each p subscript is a prime number, and each k subscript is a natural number. Now, what's important about this result is that n is uniquely expressed in this format, which means that there's only one version of it. So, stated differently, n has only the expression given above as its prime factorization. Okay, so for example, going back up to this guy right here, let's say 7,872, 2 to the 6th times 123 is the only way that you could write n in its factored format based on the fundamental theorem of arithmetic. So with all that said, this implies that 1 is not a prime number. Now, your mission as algebros is to let me know in the comments as to how the fundamental theorem of arithmetic would imply that 1 is not a prime number. Alright, and after a while, I may post a follow-up video to this giving you my explanation as to why 1 is not a prime number. In the meantime, stay mathy, my friends, and I'll catch you in the next video.